Hey everybody, and welcome back again. So today we're going to continue on talking about mechanical advantage. This is the next step to looking at forces and simple machines. And so we're really going to be interested into why did we ever develop tools? Why are tools important to us? And it all comes down to mechanical advantage, and that's going to help us decide, well, why would I choose this wrench over this wrench? What makes one better than the other? If I was looking at a set of pliers, while they're a little bit different shape, why would I use this set of pliers on something that required more force than this set? And so we're going to take a look at what mechanical advantage is. So this whole idea of mechanical advantage goes back to our friend Archimedes, the guy who was in a bathtub and thought about displacement and stuff. Well, he also had a saying that if you give me a lever long enough, I can move the world. And so mechanical advantage is all about distance. And we're going to take a look at some of these ideas of distance here in a few minutes. But if we can take something and move it with less force over a further distance, that gives us some advantages. And those advantages are mechanical advantage, especially if we have to use less effort. And so we're going to take a look at a couple explorations here and show you what that trade-off is and how it works and why we use tools that are different sizes. So I've got this little set of hardware here that you've seen us use in the past, and it was 175 grams, and it took me, on this scale, it took me 1.75 newtons to lift it up. Okay, well, what I've got here is I've got a really crude lever setup. So this is just to demonstrate some mechanical advantage. And what I've got here is I've got a really short arm here on one side of the lever and a really long one over here. So it has to move more distance. Now I know this is going to be upside down for you, but we're going to take this, we're going to put it on the end here. And you'll be able to see that it takes a lot less force to lift this than the 1.75 newtons that we had before. So, and here we go. And I'm actually lifting it now, and it's about 0.5 newtons. So with about 0.5 newtons, I can take this and lift it up. So that's a dramatic decrease in the amount of effort that we took. And that's a good example of mechanical advantage. So another way to think about mechanical advantage is the amount of distance that something has to travel. So right now, I've got this lever again set up here. And if I move this end up here, you can see that it's set up far bigger distance above the table compared to what it will be when it's level here. So I'm going to level these off. And so you can see that just traveled the thickness of that pivot point. So it only came up a little way. However, look how much further this end has to move in order to get level. So it's a big difference there. So we've traded more distance to move compared to being able to use less force. So simple machines are always a trade-off. Mechanical advantage is always a trade-off between the distance that something moves and the amount of force that it takes. So now to build off of that idea, I've taken the lever and I put some markings on it for distance, and we're going to get into how we can use this distance to calculate things in a few moments. But I've got these two objects. I've got a heavy piece of hardware here, and then I just have a little nut and bolt here, and you can see just by looking at them that their masses are quite different. And so I'm going to take this guy and I'm going to put it right here at the 15 centimeter mark. And so this is 15 centimeters from my pivot point, and I've got my pivot point marked here. And then I'm going to take this little load and I'm going to use this in order to actually lift that other piece. And I've marked out some distances here away from that other pivot point. So on this side at 30 centimeters, if I put that bolt there, I can actually lift up this piece of hardware right here. Okay, so 30 centimeters away compared to 15. So I've got twice the distance, but I only needed probably about half the load in order to lift that, or half the effort in order to lift that load. So that's just a brief overview of how mechanical advantage works. You have to remember it's a multiplier. It's how much you're going to make the little bit of effort you used, how much is it going to be worth against the load? And so we can use these simple machines and we can make these force multipliers or mechanical advantage. And now we're going to start calculating what the mechanical advantage can be based on if you've moved something different distances or used different amounts of force. It really works out to be the same, and we're going to take a look at that right now. So now we're going to take a look at how to calculate some of these mechanical advantages. And the first way that we're going to look at using is we're going to look at what happens when we use distance to calculate our mechanical advantage. So let's take a look at the first example here where we've got our lever. And let's say that we took the distance from the pivot point to where the load is. And this is going to be, let's call it 10 centimeters. And let's say that the effort, even though it's obviously a lot smaller, let's say that its distance away from the pivot point is 30 centimeters. So this gives us a way of looking at the amount of distance that has to be traded off. So we can go mechanical advantage, and we're always going to just use that MA as our abbreviation. So we're going to go effort distance divided by our load distance. And load is always something that you're trying to lift. So in this case, we had 30 centimeters divided by 10 centimeters. And I don't know if you can see this, but the centimeters are actually going to cancel each other out. And 30 divided by 10 equals 3. So this is why mechanical advantage is just a multiplier. There's no units to it. So in this case, the mechanical advantage of that situation is 3. Now here's an interesting one that many of you probably wouldn't think about. I've got this little triangle down here, and the triangle is actually like a ramp. Like if you imagine that you used a ramp to get something to another place. Well, if the top of this ramp was 2 meters high, to lift a load straight up would take some effort. But if I used a ramp that was, let's say it's 10 meters long, that's a long ramp. But let's say that from the start of the ramp to the end is 10 meters. That gives us a mechanical advantage. And again, we can look at the distance traded off. So we're going to take that effort and put it up the ramp and compare it to the amount of height that it would normally go, or how far the load is moving up. And we would get 10 meters divided by 2 meters. That would give us a mechanical advantage of 5. So that ramp would have a lot of power to it. So that's one way that you can look at mechanical advantage, is how much distance did you trade off. So now when we're looking at forces for our mechanical advantage, things get a little bit different. So we're going to take a look at this. Let's pretend that I've got a load here of, let's say 28 newtons. And I'm going to put in a force of 7 newtons to make it go up, or to lift it. So what we're going to do is the mechanical advantage, I need to compare how much effort I'm getting out compared to how much I put in. So how many groups of this 7 fit into 28? So I would say that my output, or my load that I'm lifting, is 28 newtons. And the amount of effort I had to expend was 7 newtons. So remember, I'm going to go my load amount compared to my effort amounts, or load force compared to effort force. And so in this case, 7 fits into 28 4 times. So we have a mechanical advantage of 4. Another thing you can do with this is, if we had a mystery on one side of this, we can figure it out. So let's say that I could apply 6 newtons of force. That was the biggest amount of force I could input here. And I want to know, how much could I lift? Well, I could take a look at this, and I could say that the load that I could lift is going to be my mechanical advantage multiplied by the effort I can put in. it's going to be my mechanical advantage of 4 multiplied by the 6 newtons that I can input. So the most I could possibly lift in that situation would be 24 newtons.